All right, video 3 for today. So, page 4 to start here. We've got a review of the double angles, right? So we've done this, we did that last time, proved it, proved this, proved this, proved this, and then just kind of showed that. All right. I mentioned last time, and I didn't know that we were doing it, or I forgot that we were doing it, that one of the uses of these is actually to prove these, they call them power reducing formulas. Okay, and the reason they call them power reducing is, well, you go from, for example, a sine squared to just a cosine, right? Not squared. You go from a cosine squared to a cosine. You go from a tan squared to a cosine. Okay, and if you look, for sine and cosine squared, right? Well, those involve cosine 2 theta, cosine 2 theta. So these identities are actually proven from taking, let's see, this expression here, right? And solving for sine squared. So if you can prove this, which we did, you can isolate sine squared. It's going to be cosine 2 theta minus 1 divided by negative 2, which is the same as 1 minus cosine 2 theta over 2. So that's really how you prove this, right? The way you prove this is you take this identity for cosine 2 theta and you say, all right, I want to isolate this. So if I want to isolate this, I'm going to move the 1 over as a plus, right? That's the 1 plus cosine 2 theta. And then I'm going to divide by 2, all right? The tan squared one's a little bit trickier, right? So let's look at that actually. Sure. Let's take this, right? And try and isolate it. Nah, I don't want to do it that way. Sorry. Let's do this the easier way. All right, so we'll prove this one. But please realize, and I'm going to highlight actually, that these two are linked to these. Okay, so I want to mark that before we do the tan squared one. So let's just take a pink and let's say that this, right, this comes from this. And let's take like a green and say that this comes from, I'm going to go this way, this comes from this. Okay. And then the blue, yeah, I guess I need to change now where I'm going with the blue arrow. Oh no, I guess it'll be okay. But let's do this. Tan squared theta is really sine squared theta over cosine squared theta. Okay? And that, if we just take these two right here, well, that's going to equal 1 minus cosine 2 theta over 2, right? Because this expression is equal to that by this. And now I'm going to need to divide by this, because that's cosine squared. So that is going to get divided by 1 plus cos 2 theta over 2. So now you guys are probably saying, well, look, I've got this thing over this thing. They both have a 2 in the denominator. Can those cancel? And the answer is yes, absolutely they can. Okay? So this turns into 1 minus cosine 2 theta over 1 plus cosine 2 theta. All right? And now we've proven that tan squared theta is that. Okay, let's keep moving on. Use the power reducing formulas to prove the following. So these are the half angle. All right, so you could do this with double angle too, but yeah, we'll do this way. So if I want to isolate, for example, let's say I want to solve for sine theta over 2. Well, I can start with this, and I can just label this theta over 2, and then solve by square rooting it, right? So I'll just do this once. If we take this and we rewrite it, we could say that sine squared of theta over 2 is equal to 1 minus cosine theta over 2. Okay, so all I did there was, instead of having a theta, I got a theta over 2, and then instead of a 2 theta, I've got theta over 2 double, which is theta. And then to isolate this, you just take the square root, right? So why is that? If we just square root both sides, square root that, we get the plus or minus, and we derive that. Okay. Same way for cosine, and for tan, it's a little bit more complicated, right? Tan theta over 2. Let's look at that one too, I guess. So I'll use maybe like this. So let's use this color. Okay. So if I take this and I rewrite it, then I could say that tan squared theta over 2 is equal to 1 minus cosine. Now it's not going to be 2 theta anymore, it's going to be theta over 1 plus cosine theta. Okay? And then if I square root, I get that tan of theta over 2 is equal to the square root of 1 minus cos theta over the square root of 1 plus cos theta. Okay? And where's my mouse? So, and sorry, I need to put a plus or minus, right? Where is my pen? So there's a plus or minus here. Okay, so this, if we now square both of these, right? This becomes 1 minus cosine theta, which is there. And this becomes sine theta. Let me show you what I mean. So this is equal to, this is equal to plus or minus square root 1 minus cosine theta over square root 1 plus cosine theta. But now I'm going to multiply top and bottom by 1 plus cos theta. Okay, 1 plus cos theta. Cos theta, I don't need that. If I do that, the bottom is just 1 plus cos theta. And if we multiply these together, you get 1. The middle ones cancel out, minus cosine squared, which is sine squared. But when you square root sine, you get, when you square root sine squared, you get sine. So that's sine theta. Okay, which is what we have right here. If you do the opposite, let's do maybe another color now. Let's take this, but now we'll multiply the top. We'll multiply the top and the bottom by the top. All right, so this could equal also the square root of 1 minus cos theta times itself over 1 plus cos theta times that same thing. Right? So we're multiplying by this because it's a form of 1. Okay? And that's going to equal 1 minus cos theta on the top. And the same as before, when I multiply these two and a FOIL, I get 1. The outside inside terms cancel, minus cosine squared. Sine squared, square rooted is sine. So maybe I should write that. That turns into 1 minus cosine squared theta, which is 1 minus cos theta over sine theta. Okay? So here, actually I like this yellow. Let's see how that looks. We've got two different expressions. You know what? I don't like that. We have two different expressions that are equal to tan of theta over 2. Okay, and again, the way we got that, we started with tan squared theta over 2. From here, we wrote out what it was equal to. We square rooted both sides, and then we isolated. And we got two different formulas for the same thing. Okay. One example here, and then, the solution is right there. So, okay, well, a couple ways you could do this, maybe. I won't make a video because you have the solution there. Simplify each of the following. You also have the solutions. So, I hope, guys, that that's enough. And that you feel comfortable with us going through this material. And again, this is pretty, pretty tricky stuff. Yeah, let us know if you have any questions. Just trying to look at this because I want to clean up some things here. Just checking that everything looks right. Okay. Homework. Should point that out. Homework is out of the old school textbook, page 831. Here are the problems. I think you'll have solutions to all these. If not, I believe we have answers that we'll post. Okay, guys, keep at this. This is tough stuff, but you're almost through the course. So keep your mentality focused, and write your teacher. Get in touch if the things are